Okay, so this is my project on personal health data monitoring and analysis. Just a brief description of my project. So I'll be generating some health data, predicting number of calories burned daily based on some features like weight, height, water intake, number of steps walked, etc. I'll be training a regression model on this data to be able to calculate the number of calories burned for some new test data. With this test data, it will be like I'll generate the test data, I'll pass it to the Kafka consumer and then read it back in and test on that data. I'll be doing the same for a classification model which will assess this category based on some health features. There will be another classification model for predicting whether the person will suffer a stroke in the near future based on certain health parameters. And finally, there's another model for predicting if a person has sleep disorder. This data, the first model I use is a model I have taken from Kaggle, while we see that the accuracy is not that good. So I'm going to generate a new data set, improve the accuracy, recall, and F1 score of the model to make better predictions. And there are some plots of performance and some plots for exploratory data analysis included with this. So let me start running the code now. This function is used to generate random numbers from normal distribution using the Box-Miller transform. This is the baseline metabolic rate, which is used for finding the base number of calories burned per day. And then this function is used to add some noise to the data. And now I'll generate the data where the number of steps walked, the hours of the person is exercising, the sleep duration, and the amount of water intake in liter, and the speed of the person are all normally distributed with the mean and standard deviation defined here. Now I'll be generating the data using the normal distribution, finding the duration and the calories burned according to this formula, and then creating the data frame and adding the noise. After that, this function is there to add the data for individual people. Like I'll be selecting a mean and standard deviation for the person's height and weight as well, and for the age as well, and I'm also choosing the starting date randomly and generating the data for 90 days. After that, now since generating the data will take quite some time, I'm going to be using some data which I've already generated earlier. So I'll just be reading this data in over here. So applying the vector assembler to assemble all the features together, then splitting the data into training data and test data based on an 80-20 ratio. Then I'll be training several ML models on this data. So I'll be creating the test data, which is going to be useful for the generate data. 1 minute. Yeah, I did not run this, I think. Yeah, so the test data is generated. I'll just convert this into Spark data frame and apply the vector assembler on this too. And then I'll be using linear regression to predict the number of calories burned. Yeah, so you see that the percentage error on the trained data is 1.07, on the test data is also around 1.07, and we see the plot of the predictions. Now I'll be using decision tree regressor to carry out the same, train on the test data and predict on the train on the training data and predict on the test data. So the error on the test data is around 3.7%, and these are the predictions. After that, we can again take a look at the predictions for gradient boost regressor. Yeah, so we see that the percentage error on the test data is 2.33, and these are the predictions. For the random forest regressor, we see that the percentage error is around 2.34 once again, and these are the predictions. Clearly the best model is linear regression. Now I'll be generating some new test data. I'll be sending this data to Kafka and then loading it back in to test it. So this is where Kafka will be used. So I need to create a new topic for this. So my topic name is going to be calories. So I'll be creating this topic. Yeah, so the calories topic is created. Now I need to run the producer file. There's the producer file. Now I'll be running the consumer file similarly. Now I'll be running this code to send the data frame to Kafka. And so now we can see that it has sent this data. Just waiting for the data to arrive here. Oh, it went to the wrong one. 1 minute. Yeah, now it should have arrived. And yeah, we see that the data has arrived here in the consumer. So now I'll just be running this to check the connection. We see that we have connected to the to Kafka at this local host. Now I'll be receiving the messages back from Kafka so that I can train them. I can test the model on it. So you see that we have got the data back. Just checking that all of the rows are there. It had 90 rows. Now I'll be testing the linear regression model on this data. So we see that the prediction is quite decent. It almost follows this line. And now I'll just make some plots of the generated data. So we see that this is the plot for the steps over time, this is the plot for calories burnt over time, and this is the plot for sleep hours over time, this is the plot for water intake over time. We see that it is quite random. So now I will use the dataset which has some information about vital human signs to predict the risk category of the patient. So I'll be loading in the data first, of course, printing the schema and just looking at the summary and just looking how many categories of the risk category are there. So there are 2 categories and we see that there are around 2 lakh rows. Checking for null values, we find that there are no null values. And I apply the string indexer on the 2 string columns, gender and risk category. Then just applying this, and then what I'll be doing is I'll be extracting the time of day, hour, minute and second to use as a feature, as the time of day might affect the health of a person but the exact day does not affect health or risk status. So now I'll be applying this to obtain the new data frame, and now I'll be splitting the data into training, validation and test data. So I'll be training the data on the training data and then comparing the performance of the models on the validation data and finally passing the testing data to the Kafka. So first I'll be training the decision tree classifier and plotting the decision matrix, which we see that the accuracy for the classifier is 0.986, is pretty high. Weighted precision and recall scores are quite high for this. And then we look at the accuracy of the logistic regression model. I have not defined this, 1 minute. Yeah, this is the confusion matrix. We see that there aren't too many false predictions. Most of the predictions are correct. We see that the performance is slightly worse for the logistic regression with a precision of 0.815. Now I'll be training it on the random forest classifier and once again plotting the confusion matrix. We see that the performance is even better than the decision tree with almost no misclassifications. Now I'll be trying out the gradient boost classifier and plotting the confusion matrix again. The accuracy is 0.984, and we see once again very few misclassifications. Now again finally trying the support vector machine classifier. So it's still training. In the meantime, you can look at the plots. So you see that the GBT classifier performs the best, and the support vector machine, so we have got the accuracy at 0.814, which is not that great. I can just plot the accuracy and check that the decision tree, random forest and GBT classifier all have very similar accuracy, and same for the precision and for the F1 score as well. And now finally a summary of all of the algorithms, and I'm going to be using the GBT classifier here as the best algorithm, although the exact best algorithm may depend on the splitting. So here it would be random forest, but on other splittings I have seen that the GBT classifier works better. So now I'll be testing this classifier on the testing data. So once again I'll be sending this to Kafka. So for that I have to create a new topic, so I'll be doing that right now. Yeah, so I'm going to be calling it risk underscore category, the topic. So it's been created. Now once again I need to start the producer and the consumer. Here is the producer. Now finally I have to create the consumer, the Kafka consumer. So another command prompt for that. Consumer now should be ready. Now I can run this. So it has sent the data, which we can check that the data is arriving. Now it has probably finished. Now I'll be consuming the messages again from back from there. Now it gets all the data back. I'll just convert this into a Spark data frame for ease of testing. So I'll be testing the data for risk on the GBT model. You can see that accuracy of 0.9836 and similarly high values of precision, recall and F1 score. So I could also try it out quickly on the random forest model. We see that very similar accuracy of 0.988. And now we can view the predictions. This is what the predictions are like. So now I'll be loading in the stroke prediction dataset. So this is quite a small dataset, so I haven't implemented the Kafka for it. So I'll just quickly run through this dataset because I wanted to display how we could have a model for stroke prediction as well. So here I'm checking what are the different categorical values in each of the columns, and once again we look at the schema and we apply the string indexer and drop all the string columns. We see that there are 5,100 data points, and there are very few data points where actually the stroke did happen. So only 249 of them. Now I'll be checking for null values. We see that there are some null values in the BMI. So I'll use two different ways to impute these missing values. One will be the mean, other will be the median. And I'll compare the performance of the machine learning models for the different imputations. So after doing the imputation, we see that there are no null values left for either of the data sets. I'll be splitting both into training and testing data based on 75-25 ratio. Now training using the decision tree classifier on the mean imputed data, we see accuracy of 0.946 and the confusion matrix, which looks like this. Now on the median imputed data, we see that it has the same accuracy and the confusion matrix is almost exactly the same. So the type of imputation does not really matter. So once again we train all these different classifiers, very similar accuracy for logistic regression as well. And on the median imputed data also almost same performance. Random forest has an accuracy of 0.948 once again, the very similar confusion matrix to earlier. On the median imputed data as well, accuracy is almost the same. Almost the same confusion matrix too for gradient boost as well. On mean imputed data, almost same accuracy, 0.946. On median as well as mean imputed data, so gradient boost for that accuracy 0.945, almost same for both mean as well as median imputed data, almost same for support vector machine as well. So I'll be plotting the accuracy. We see that almost all algorithms have the same accuracy, precision and F1 score. So now I'll be analyzing sleep disorder based on some relevant features. So the first dataset I use is a dataset taken from Kaggle. We see that there are only 374 rows in this. So this is why I'll be generating my own dataset later on. So that performance is better. So I look at the different types of occupation here. See that there are many types of occupations, and blood pressure is given in this string form, which I'll be now splitting. So checking for null values, there are none. Now we see that the blood pressure column is a string in this form, so I'll be splitting it into systolic and diastolic blood pressure and dropping the original blood pressure column. Then applying the string indexer on these columns to remove any string columns, then dropping the string columns, and then selecting the physical activity level, then splitting it into training testing data. And now using decision tree classifier, we see that accuracy is 0.905. This is what the confusion matrix looks like. For logistic regression classifier, is a very similar accuracy of 0.905. Again, this is what the confusion matrix looks like, very similar to the decision tree model above. Now using random forest classifier, it has a slightly better performance of 0.929 accuracy. Now plotting the confusion matrix again, it performs a little bit better than the previous two models. Now using naive Bayes, see the accuracy is quite a bit lower at 0.635. This is the confusion matrix also confirms there are a lot of false misclassifications over here. Now I'll be comparing the different metrics. We see that random forest performs the best in as for all the cases, accuracy, precision and F1 score. So now I'll be generating some synthetic data of the kind being used above. So I've used different choices, like in some cases I've used the random normal distribution. In some cases I've simply picked a random value in some from this list. In some cases I've chosen a random integer which I think follows the uniform distribution. Then I'll be using some conditional logic to refine which sleep disorder a person is affected with, and now I'll be generating a dataset with 50,000 rows. So this is the dataset. Now I'll be plotting some variables for the first 40 rows. So this is the quality of sleep. We see that it is quite random. Now the daily steps is also random, and the physical activity level is also very random. Heart rate also, it varies from 50 to about 100, which is a normal range. So now I'll be saving this as a CSV and then rereading it in using Spark. Then again I perform similar operations, like I check what are the kind of sleep disorders, like how many sleep disorder types are there and how many people are affected by them. Again, split the data into 80-20 training and test data. Now I'll be using decision tree classifier to predict. ETC accuracy is 0.995, and the confusion matrix confirms that there are almost no misclassifications. Logistic regression performs a lot worse with accuracy of 0.701, and we see that there are quite a lot of misclassifications this time. Random forest classifier gives accuracy of 0.988. The confusion matrix confirms that there are very few misclassifications once again. Now naive Bayes does quite badly, accuracy of only 0.48, so we will probably not consider this model for further analysis. Now I'll be plotting the accuracy and F1 score. Clearly the decision tree and random forest are the best models, with decision tree slightly better for this particular split. Just rerunning it for a second. Yeah, now you see that decision tree F1 score is the best. Let me rerun it once. The classifiers. Yeah, so accuracy of 99.5% for decision tree, high precision recall and F1 score values, almost no misclassifications. Now for logistic regression, accuracy of 0.701, so this performs a lot worse. Next we have the random forest classifier, accuracy of 0.988, relatively high precision recall and F1 score values, once again almost no misclassifications. Naive Bayes performs quite badly with a lot of misclassifications. So now just comparing the accuracy, see that decision tree is slightly better than random forest, but the other models are far worse. And same for precision, and same for the F1 score as well. Just comparing the performance of the algorithms on the synthetic data and the Kaggle dataset. So we see that the models perform a lot better on the synthetic data, especially for decision tree and random forest, whether it be accuracy or precision or F1 score. Now I'll be testing the decision tree regression algorithm on some generated data, since that was the best algorithm we had. So this is the function for that, and I have already generated some data earlier because it will take long to generate. So I'll be just reading that data in. You see that there are 2000 rows. So now I'll be passing the generated data to a Kafka consumer. So for that I'll have to create a new topic. So I'll do that in a second. Yeah, so the topic name will be sleep. Yeah, so the topic sleep has been created. Now I'll be again creating the producer and the consumer files. So Now I'll be creating the consumer, running the consumer file in the command prompt. I added the slash actually, that's why there was an error. And yeah, now I'm going to be passing this generated data to a Kafka consumer. You see that we have got the data here in this command prompt in the consumer file. So now I'll be loading back the data in from the local machine. So we've got the data here, and now creating the Spark data frame and then testing the data model, and we see a very high accuracy of 0.989 and precision of 0.990, and we see that there are almost no misclassifications. And this is for the random forest model. We can do it for the decision tree model as well, and you see an even better performance accuracy of 0.996. There are only 15 misclassifications out of 5,000 examples. This was quite a successful model. Now just to compare the prediction and the actual values, and we see that there's almost a perfect match. Yeah, this was my project. Thank you for listening to the video.